Extreme weather events have been in the news a lot lately. Hurricanes, tornadoes, superstorms, and prolonged drought are not only becoming increasingly commonplace, but tragically increasingly destructive. However, perhaps the biggest threat humanity faces as the Earth continues to warm is sea level rise. In the last few years, Greenland is at its highest temperatures in recorded history. It has also experienced the first full surface melt of its ice sheets in our modern era. Now, these two events have so much potential impact on the world's oceans that many scientists have become quite concerned. So we went to Greenland to see what's happening on the front lines of climate change. Greenland's glaciers are in free fall. Every year, Greenland loses over 140 billion tons of ice. This net ice loss is now responsible for a significant amount of our current global sea level rise. Now, some of the fastest and most alarming melts are occurring on the country's western coast, where many glaciers meet the warmer ocean waters, causing massive icebergs to break off from Greenland's ice sheet in a process known as calving. To witness some of these events firsthand, we met up with one of the world's leading experts on Greenland's ice sheets, Dr. Jason Box. In his role as glaciologist for the Geological Survey of Denmark and Greenland, Dr. Box has unique insight into the data and science that helps us understand Greenland's glaciers and the factors that are causing the extreme melt there. Our route out to the ice sheet took us directly over some newly deglaciated land. Now, this area would have been totally covered in ice up until recently, but because of the melt, we had to fly fully 5 miles further inland just to reach the glacier itself.
Just 10 years ago, much of what you see here was covered in several hundred feet of ice.
Wow. So all this is brand new. This is all freshly deglaciated, so we've had the glacier retreat.
Yeah. Just this region here has lost enough ice to supply Los Angeles with fresh water for about 2,000 years.
Wow.
It's hard to put numbers on this that aren't astronomical.
When you first see it, the ice sheet itself seems to go on forever. And in many places, it's miles and miles thick. It's then you realize just how much water is tied up in it, because the ice sheet covers about 80% of Greenland, which in turn is about 3 times the size of Texas.
We're here on the southern lobe of the Greenland ice sheet with Dr. Jason Box to actually measure how fast the ice sheet is melting, because it's melting at such an alarming rate.
Yeah, okay, they're 2 meters.
How much will this shelf melt in the next year?
This site's been melting more than anywhere in Greenland at the surface. Last year we measured 9 meters.
9 meters?
9 meters of melting, so that's, like 27 feet of ice melt. The size of a house is this how much is...
In 1 year?
Yeah.
So Dr. Box is going to put the pole down into the ice. So if you can see all the way up to there, that's how much ice from this shelf is melting.
Every year.
Dr. Box's method to track ice melt here is actually really simple. After drilling down into the ice, he places a long 30-foot pole into the ice shelf and leaves it there. When he comes back in a year, he measures how much of the pole has been revealed. Now, the ice on this glacier is melting so fast that the flag you see here will be 27 feet higher in the air in just 12 months. One of the reasons the ice is melting so quickly is visible right on the surface. Contrary to what I thought before traveling to Greenland, the ice sheets are not actually vast expanses of gleaming white ice and snow. Because due to increased pollution and airborne soot, the ice is actually very dirty. Now, this dirty or dark ice accelerates melt because its color absorbs the heat rather than reflect it.
So you can see that the dark ice here is melting down. Why does that happen?
Well, the dark material absorbs about 3 times more sunlight than if it weren't here, and that's why it's melting more here locally. There's always been some dark material on the surface, but We think that there should be more if wildfire is increasing, and that is documented.
The soot comes by air to here.
Yeah, the question is if climate warming creates more fire, that's going to be depositing more light-absorbing material on the ice.
And it's sort of cyclical. The hotter it gets, the more fires. The more fires, the more
Right.
soot. The more soot, the more dark ice. The more dark ice, the more they melt.
Rising global temperatures are making the natural fire season not only much longer, but also much drier, which in turn leads to more soot and therefore more black ice. And another contributor is the massive amount of industrial pollution that is carried to Greenland by air currents. These particles land, then literally drill down into the ice, thereby exacerbating the whole process.
You can see the hole goes all the way down there.
Yeah, and then it looks like this fracture here, it may have been that the water filled up and then forced this crack open. We call it hydrofracture, and that's when water drains down into the cracks.
Yeah.
Because water is heavier than ice, and it actually can force the cracks open.
The meltwater actually hydrofracts down into the interior of a glacier and lubricates the entire glacier from within, causing it to break apart and calve into the sea.
Then the next thing is, okay, how fast is it melting, and,
Right.
and how quickly would that contribute to sea level rise?
Right.
Climate change has outpaced the worst case scenarios that was observed 20 years ago. And so it's just melting as fast as it can here.
If all of Greenland melts, how much would the ocean rise?
Well, Greenland contains about 7 meters or 21 feet of global sea level equivalent.
21 feet.
Yeah.
So if it melted, 21 feet.
So just to be clear on what that means, if all of Greenland's ice melts, which is now being argued as a distinct scientific possibility, then 80 of the world's 100 biggest cities would be underwater. Now, the worst case scenarios Dr. Box and I were talking about were based on the recently released Intergovernmental Panel on Climate Change, or IPCC's, 5th report, which concludes that we have dramatically exceeded our previous worst case scenarios. Now, in order to understand what the findings of the latest IPCC report really mean, and to make sense of what we had just seen in Greenland firsthand, we wanted to talk to someone who could give us a consensus of what the global scientific community thinks about these issues. So we contacted Dr. Gavin Schmidt, a climatologist at NASA and a well-respected voice in the oftentimes contentious dialogue that surrounds climate change.
So the IPCC 5 report just came out, which shows that we're well ahead of worst case scenarios that we had from the past decade. Can you give us some context of what is going on?
Change in the Arctic sea ice is way ahead again of the predictions that we made even 5 years ago. You know, we have sea level rise coming from the melt on Greenland. We have more sea level rise coming from glaciers in mountains around the world that are melting. We have more melt coming from West Antarctica. And then we've got the warming of the oceans. We're pouring effectively enormous amounts of heat into the oceans year on, year out, and that's causing the oceans to expand. All of those things add up to the sea level rise that we're seeing, and we anticipate that that's going to accelerate over the next 50, 100 years. To slow down the current rate of sea level rise, we need to stabilize glaciers and Greenland and stop adding so much heat into the system. We need to cut emissions of mainly carbon dioxide by about 80%.
80%.
80.
So we have to cut emissions by 80% in the next
few decades.
What happens if we don't?
Well, then we're talking about a scenario where sea level rise is accelerating. It could reach levels by the end of the century of 4, perhaps 5, perhaps more feet, and then it will continue on.
And our emissions are going up, not down.
And our emissions are going up, not down.
How much of this crisis is man-made?
All of it. We look for the fingerprints of change that are associated with the sun, or from volcanoes, or from natural variability in the ocean, and we look for each of those fingerprints, and they don't match. This is a crime scene that is so covered in our fingerprints, there is no credible way that you can say it was somebody else. But it's not going to stop. Even if we stabilize temperatures, we'd still be seeing sea level rise continue for centuries to thousands of years.
So even if we stop, sea level rise is going to continue. It just hopefully is going to slow down.
That would be the hope.
What happens if, going forward, we keep beating our predictions?
Well, then we're talking about a scenario where cities like Shanghai, New York, Calcutta, all of these places are going to have to either retreat from the coast or build barriers to protect themselves. And if you're not in a city that can afford that, you're going to be out of luck. Those cities are just going to more and more disappear.
Now, this would all be bad enough if it were just Greenland. But now, Antarctica, the largest deposit of ice in the world, is starting to experience large amounts of net ice melt as well. What happens if Antarctica and the Arctic start melting at the same rates as Greenland?
West Antarctica, we're seeing very rapid changes there. So it could well be that Antarctica will start to melt at the same rate as Greenland is.
If Antarctica starts melting at the same rate as Greenland, we're in for trouble.
Indeed. Sea level rise is the one problem where there are no winners. Now, if you have a change in rain patterns, if you have a change in temperature, you know, somebody might be able to benefit from that. Sea level rise, nobody wins.